So question 7 of this paper is asking us, first of all, to use logarithms to solve the equation 8 to the power of 2x plus 1 equals 24, giving your answer to 3 decimal places. So hopefully by the end of this, you'll see that your answer should be x equals, and then a number to 3 decimal places. Now, there's a couple of ways about doing this question. I'm just going to go through the way which I think will be easiest to do and uses the less calculations as possible. Now, using our information or using our knowledge, the fact that log to the base a of a is equal to 1, we can think about taking logs of a particular base here. Now, I'm just going to rewrite the question to begin with. So 8 to the power of 2x plus 1 equals 24. Now, if I take logs to the base 8, we can instantly eliminate the 8. So if I take, like I said, logs to the base 8, I'm going to get 2x plus 1 is equal to log to the base 8 of 24. Remembering just the log rules here, so if I have log of any base really, a to the k is the same as writing k log a. And then just using my calculator, I could type in log 24 to the base 8. You would end up with 2x plus 1 is equal to 1.52832, etc. Taking 1 away from both sides and then dividing by 2, you should end up with the answer to 3 decimal places of 0.264. Moving on to part 2 of this question, we're now trying to find the values of y such that this is true. And here we're going to have to use a couple of log rules, in particular that log of a minus log of b is the same as log of a divided by b. And also we can see here that we have a 2 log y, which we can rewrite looking at the rules we did for the first part of the question. You can rewrite that as log 2 to the base 2 of y squared. Doing that on its own will get you 1 mark in this question. So moving on to the next bit of the question, we can see that actually there's a minus sign here. Both of these things are being taken away from log of 11y minus 3, which means that we can rewrite this entire side, or entire equation, as log of, in brackets, 11y minus 3, sorry, that's to the base 2 of 11y minus 3, all over 3y squared, which equals 1. Now I have just a single log on the left-hand side. I can do the reverse of logs, or sometimes called anti-logs. I wouldn't recommend doing it at this point here. Apologies for that. I wouldn't be able to do it at this point here. Always try and put it together so it's one single log on one side, so it's all into one form. It makes life a lot easier for you and you're less likely to make mistakes. Now I'm at this point and I want to make it so it's y equals. I'm actually going to take anti-logs or do the reverse of logs, which essentially means is I'm sticking a 2 underneath everything here. So now I've got 2 to the power of log base 2 of y minus 3 over 3y squared equals 2 to the power of 1. 2 to the power of log of anything with its own base cancels each other, cancels it all out. So actually I'm here with 11y minus 3 over 3y squared, which is then just equals 2. And now you've essentially just got an equation that you need to solve, and hopefully you guys can see that timesing it by 3y squared, you will end up with 11y minus 3 is equal to 6y squared. Yep, you've basically just got a quadratic equation that you now solve. So moving everything to one side, I'm going to move everything over to the right-hand side to keep the 6y squared positive. I'm going to get 6y squared minus 11y plus 3 equals 0. Factorizing to get in two brackets, and you can just use, if you have a graphical calculator, just use the polynomial function on there. You should end up with 3y minus 1 and 2y minus 3, meaning that y will equal either a third or y will equal 3/2. And that's how you get the 6 marks for this. I hope that helped. Thanks.